All right, let's get started. There we go. That's the right. Nope, wrong slide. All right. So humans have always used tools to make things. And some humans have become very proficient with their tools, and they've dedicated their lives to their crafts. And when you've got skilled people with good tools, you end up with masterpieces. This is my favorite painting. But if you've got bad tools, you'll end up with a bad product. Here's my rendition of that painting. I know, beautiful. Put it in a museum tomorrow. But they say it's a poor craftsman who blames his tools. And there's some truth to that, because some people, given the same tools as me, can make a way better picture. My name is Omar, and I'm here to convince you that sometimes it's not you, it is the tools. And I'm here to give you the good news that we are all programmers, or at least we all work in tech, and we get to build the tools we work with. So we're going to talk about intuitive API designs, how and why we should write code for humans. But before we start, let's set some ground rules maybe. We need to work in on a definition of what is an API, because I had some trouble with this. So according to the dictionary, an API is a connection between computers or between computer programs. It's a type of software interface. And the software interface there is the important bit for this talk. So basically, APIs are the tools that programmers use to interact with systems. And like I said, we not only use these tools, but we build them for ourselves, for others, for strangers, for everybody. And as part of this definition, we also need to talk about what is and isn't an API. Because when I was writing this talk, I had a lot of, I won't say arguments, but spirited discussions with my coworkers on what constitutes an API. So we're going to have a little bit of a pop quiz. I'm going to show you an image, something like this, and ask you, is that an API or not? If I have a REST endpoint, is that part of an API? Yes or no? Yes, obviously. If we do something a little bit more exotic, maybe something a little bit weirder, I at least hadn't heard of it when I left university, GraphQL, also an API. Easy stuff. What if we take something like HTML? API? Not really, no. And here's the one that led to spirited discussions. CSS. CSS has a lot of things that we use in it, like Flex. And I think the way we interact with Flex does count as an API. And if you disagree with me, you can come argue with me after the talk. Cool. But with that out of the way, let's get started. What are the blueprints for a good API? When I say I want to make good tools, what do I desire from it? And it's quite simple. A good API does the thing it's supposed to do. Duh, obvious. But we want it to be powerful. It needs to be able to do a lot of things and needs to do it well. And additionally, we want it easy to use. Simple, right? Definitely not an impossible task. But I'm a software developer or a software engineer, and like many of us in this career, I look at impossible tasks and I say, it can't be that hard, right? I mean, sure, a ton of smart people have looked at it, and they haven't solved it yet. But none of those people were me. Uh, so let's restate the problem in ways that we can all understand. We want our APIs to be performant, fast, and sleek. But often they end up kind of clunky. It works, gets the job done, but it's not the best. Is there some way we could have both? Can we make APIs that are easy to use, but still really sleek and powerful and available to everybody? Well, I have spent years reading blogs. I have spent years meditating. I've spent years contemplating the secrets of the universe and the meaning of life and everything. But in the end, the APIs I build and the tools I build still look like this. They're taxis, not Lambos. So what I'm here to do today is not to give you the absolute perfect recipe for a good API, but I've been doing some reading, I've been doing some learning, and I think I've got enough to share with you guys. People have been building impressive things for a really long time. The Sphinx, for example, was built thousands and thousands of years ago. And it wouldn't have been possible without some good tools. And surely somewhere along the way, someone documented their process. Someone wrote it down and said, hey, this is what makes a good tool. This is what makes a bad tool. Uh, and so with this in mind, I visited one of these ancient wonders of the world, something the older people in the audience might recognize, this thing called a library. Uh, and I started reading a book, this book, in fact. It's called The Design of Everyday Things by a dude called Don Norman. And it's a book about how you make things for people in a way that's very intuitive. And it got me thinking, can we design our APIs to align with these principles for intuitive use? Could we make the software interfaces in a way that is compliant with how UX designers and physical objects are designed? So with that in mind, here's the plan for our talk today. We're going to talk about why do developers complain about APIs? We're going to ask and answer why haven't we fixed those issues yet if we're all so smart? And finally, we're going to steal some ideas from designers. And finally, because I forgot I had one more line here, we're going to practice how to apply our newfound knowledge on a real example that at least one person in this audience might recognize. Cool. Have any of you guys seen this meme before? It says, what gives people feeling of power? Money, status, knowing how to center a div properly. It's an infamously difficult problem, centering a div, but it's also dead simple, like really, really, really simple. And I'm going to show you how to do it now in under 2 minutes. I've just started a timer. We'll see if I actually make it. So here are some ways I know how to center a div. The first is we center using position absolute. What we do here is we say, we're just going to put this item 50% of the way down from the screen, 50% from the left, and we have to do some weird translation stuff, but that works. If anybody here ever uses this, don't. Stop. I will come physically fight you. Send me your address. A better way to do it is to center using margin auto. You set width 50% or whatever height you want. You can do it with height as well, and you just say margin auto, and it fills up the space. Why does it do this? Like, why does auto mean center? Don't ask me. But the way I prefer, and what I imagine most front-end devs prefer these days, is using flex. Flex is pretty simple. You put on the parent container, display flex, and you just say justify content center, align item center. It's perfectly centered. You don't even need to do anything on the item you're trying to center, only the parent container. Cool. That has been 1 minute and 10 seconds. Now, all of you know how to center a div. We don't need to post that meme anymore. But people still do. I'm one of them. I did this years ago. I asked, why is it so hard to center a damn div? Because I spent like 2 hours trying to figure, why is this button not in the right place? But if you ever dare say this out loud, and you guys can try this out after the talk, not in here, it will instantly summon a front-end developer who will tell you, get good. And some of them take it a step further. Some of them are real extreme. They'll go and write a whole talk about how and why you should get good. This is a talk from Escape, I think last year or the year before. You guys can go check it out online. It's real good. Strong recommend. And I see both perspectives. Because centering a div isn't difficult. It took me like under a minute to teach you guys how to do it. But learning how to center a div and what is the right way to center a div is difficult. If I'm a new software developer, I'm new to front end, I'm new to the web, I go and Google this and I get all three of these things. They all look the same. How do I know what is good and what isn't? Why on earth do I need to put that translation in? Why on earth does margin auto put things in the middle? Why does Flex have both an align items and a justify content? Kind of weird, huh? And this leads us to our first big idea for the day. And that is a good API makes it easy to discover how to do things. This sounds really simple, but gets surprisingly complex. So let's unpack it. We're going to start with a definition from my favorite book, and that is discoverability. Discoverability is how easily a user can find features, information, or functionalities, blah, blah, blah. It's how easy they can find out what to do with your product system, or in this case, API. After all, there's no point in having all of these cool features if users never find out about them. it doesn't matter that centering a div is easy if I can never figure out how to do it. And with physical items and even some like visual displays a little bit easier. After all, no one says, I don't know how to drink water. You see a bottle, you see a cup. There's only one way to use it. You take a nice big gulp. And users can see and touch the objects, and they look very different. I know that this bottle works differently to this can, but it's pretty easy. It's very intuitive. With code, it's a bit more difficult. Over here, I've got two snippets of code that I showed you earlier, and it's not easy at a glance to see how I should use these, which one is better. So how can we make it clear? We can steal good ideas from the designers. I know there are some of you in the room, so don't out me if I get anything wrong. But let's do an exercise. We're going to design a door. Now, bear with me. I know that this isn't really software design, but the principles apply. I want all of you in the room to imagine a door for me. Maybe it looks something like this. Here's a standard house door in SA. Now, for this door that you're imagining, how do you open it? Do you push or do you pull on this door? You pull? Really? Interesting. See, there's a lot of confusion. Some people say push, some people say pull. Yeah, they're not on the right. Do you twist this handle before you open it, or don't you? Some doors you can just push, some you have to twist. Twist. Is that what the room says? Finally, maybe this is even a sliding door, and this is the worst door I ever encountered. One that looked like a normal door, and I pushed it. I was like, what the hell, guys? Why can't I go? Someone had to show me you slide it. Terrible, terrible door. But there's a lot of ways you can use this door. You can push it, you can pull it. You might need to twist the knob. We don't know. It's just a hypothetical door. And maybe you're really wild and your door slides. So let's maybe try and modify this door. And you guys would have seen a door that looked something like this maybe when you were coming into the room. Instead of having a handle, it's just got a horizontal bar. And the second you see that there's only a horizontal bar on this door, we've made it clear this is a push door, obviously. And if it's a single door like this, maybe not a double door like the ones you've got outside, we have a new question. Do we push on the left or on the right of this door? It's really confusing. Obviously, this sounds really silly, but designers and architects, they spend a lot of time thinking about these. There's one final way to disambiguate this. We'll put a little strip of paint, nothing else. And now you look at this door and you're like, oh, this is a door that I push on the right. But in theory, all three of these designs work in the exact same way. They all do the same thing. Same way all the code I showed you earlier centers a div. But some of them are better than others. By signifying to the user what way that the door works, we can make it so much easier for them to understand. Anyway, this is a great exercise and would be fantastic if we were all designers or architects. But we're not. We work with code. But I did use an interesting word there, signify. It's not a very common one. So I'm going to throw another definition at you. Once again, from the book. A signifier is a perceivable cue that indicates to a user what they can do with your interface or environment. And not all of them are like visual cues. Some things are things that we've learned over time or sounds that we associate. But functionally, what a signifier is, it's a way to clear things up for our user and tell them how to use our product without them ever having to read a manual. When it comes to code, I always have to read the docs. When it comes to something like water, you just read. Don't think anyone's ever made a manual for a bottle. So how do we apply these principles to code? Because code is somewhat abstract, right? It doesn't have a physical shape. You can't just paint one part of the code a different color and expect users to know what's going on. On a push door, you can just put the letters push or pull. You can't really do that with code, can you? Well, you can. Here's a screenshot of one of the examples from earlier in my IDE. The first thing you'll note is that this one has way more color than the one earlier. And each of these colors denotes something different, right? Some of them say this is a property, this is a value, this is a comment, this is a class. And someone who's worked with these tools immediately knows what's going on here. Similarly, if you've written good documentation for your API or your component or whatever, if someone hovers over it in their IDE, they're going to get notes like this. And this is the exact equivalent of putting push above a push door. It tells you, hey, this is what justify content does. And this is great. And like I said earlier, we also have signifiers that are learned over time. And these are just simple, what's the word here? Simple conventions that everybody adheres to. And once you know them, you know how a system works. Cool. I'm going to throw another definition at you quickly from the book. It's called feedback. Who here knows what feedback is? Raise your hands. Cool. Now we all know what feedback is. Feedback tells you you perform an action, you receive some form of information in return that lets you know what happened as a result of that action. I asked you guys a question, some of you raised your hands. And with physical objects, this is super easy. For example, I play the piano, and on the piano, if you press a key, you know immediately a sound comes out. I pressed the key. And if you're very good, which I'm not, you may even know what key you pressed. But again, code is abstract. How do you give users feedback in your code? And to complicate it even further, there's often a delay between when you write your code and when you execute your code. A developer will write their code now, but it might only get run in 2 hours, 2 days, 2 weeks, 2 months. So how do you give good feedback? We're going to talk a little bit about that, and we're going to go through another example here. I'm going to take you through a real bug that I had to fix years ago when I first started out. My QA came to me and they said, oops, something went wrong. I got this picture while I was trying to buy something. And this is not great feedback. If you look at this, what went wrong? Nobody knows. I see some people here in the front row laughing. You know who you are. But I'm a developer. I can just look at the network error that caused this bug, and then I will know. It doesn't have to be on the front end. So I did precisely that. Here's what that error looked like. For any of you who've worked with HTTP, you should be groaning. If anybody has ever written something that looks like this, I will find you and I will fight you. It says here HTTP 200. That's a success code. And it has a single field, success, false, error, bad request. This is horrible. Why did you send me that it was a success if it wasn't? Unlucky for you guys, I have a picture that I took on that day of what I looked like when I read this. I looked like this. I know, exactly like this. Spitting image of me. So let's talk about how we're going to fix that, right? So here are the official HTTP response codes. We've got 100, no one really uses that. 200 is a success. And notably, 400 is a client error or a bad request. So that's the first step to fixing this. Instead of sending a 200 code, we're going to send a 400 code, and we're going to say bad request. This is instantly better feedback. Now, if I look in my network tab, I will get an error there. But this still doesn't tell us what went wrong, right? So let's add a message field. We're going to say message invalid quantity. Great. Now we know that we tried to order something that we are not allowed to. We put in a wrong number. But this could still be better, right? Let's make one more fix to this. Excuse me. We are going to add another message, or we're going to replace the message. I'm going to say quantity can't be less than 1. QAs were doing exactly what QAs do, and they tried to order 0 of an item. And now, after making all of these changes, maybe you'd look something like this. Again, it's still broken, but at least now we know why, and that smile is just a little bit genuine. But what if we could avoid this entirely? What if we never sent the users of our API down the road to failure? What if there wasn't a need for good feedback? That's going to lead us into our second big idea for the day, which is that a well-designed API is predictable. So I've talked about signifiers and I've talked about feedback. I'm going to bring up one more definition from the book, and that is the idea of a conceptual model. So users use their observation about your tool or system or API in this case, mainly through the signifiers and the feedback they receive while using it, to build something called a conceptual model. And to give you the formal definition of it, it's just a mental explanation of how the object or system works. You build up an idea in your mind of, if I put in A, I will get out B. If I put in C, I will get out an error. And it's often simplified or abstracted from the actual workings of the object or system. Who here uses a keyboard in their day-to-day lives? How many of you guys actually know the inner workings of a keyboard? No one really cares, except for you mechanical keyboard nerds. I respect y'all. But for most of us, what we actually care about isn't the inner workings of the system. Our conceptual model of it is, I press a button, I get some text out. And that's all that matters. So when we are designing these systems or these tools or these APIs, you want to make the mental model as simple as possible to understand and as similar to the underlying truth of how it works. For example, if I call array.sort in JavaScript or Python or whatever your favorite language is, I don't care how it moves data in the CPU registers. I don't even care what algorithm it is. I just want my stuff to be in order. For the sake of curiosity, who here knows what algorithm JavaScript uses for sorting? I do. It's called TimSort, made by a dude called Tim. Very arrogant, naming it after yourself. But yeah, that just proves we don't care how it works, just that it does work, and we can roughly reason how it works. But what happens when this chain of logic of, if I put in A, I will get out B, breaks down? What happens when our conceptual model of how the system works doesn't match up with how it really works? I'm going to go back to my favorite example, which is the whole reason I wrote this talk, and it is, again, the idea of flex. Suppose we have a screen, and our PM has asked us, please put an image on the screen. I want it to be centered, and I want it to be near the top. We learned how CSS works earlier, so we know we're going to put this in a flex box. We're going to say display flex, justify content center. That puts it in the middle. We don't want it perfectly centered, so we're going to put align items flex start. Now it's at the top. Absolutely perfect. We can all go home. Cue the applause. But then our PMs do what PMs tend to do, and I'm looking at you, and they say, can we add something to the screen? Let's put a button in. And I'm a developer. It's 2 seconds. I'm just going to put in button. Disaster. Suddenly, my items aren't really centered anymore. I want the button under the image. But I've read documentation. I know how this works. All I need to do is change my flex direction to column. So I'm going to do that. And suddenly, my items aren't centered anymore. What the hell, guys? Why did it go from being centered in the middle of the page to being centered now horizontally or vertically? Why on earth has it gone from the top to the middle and from the middle to the left? I'm looking at this and I'm like, what the heck? I changed one thing. Why did everything else break? My mental model broke down. And at this point, I'm going to reuse an older slide. I said, why is it so hard to center a div? CSS sucks. And immediately, yeah, I agree with you. Nice. Immediately when I said that, a developer came in running right next to my computer, summoned from thin air. Then they told me to get good. And then they went and wrote a whole talk about it. You know who you are. So let's talk about why did my item go from being center aligned to being off. The reason for this is that I learned justify content center means it's going to center it vertically, like if I'm using justify in Word. That's how I first learned how to use a computer. But that's not really true. Justify content doesn't mean center it vertically. What it means really is that we are going to center it in the direction of the flex container. And this isn't very clear because it's called justify content. Somewhere along the way, while I was developing this, the wires got crossed. And my conceptual model no longer reflected how the system works. And when this happens, users get intensely frustrated. They've done research on this. It's one of the most hated things. And they call this thing the gap of evaluation, to use another fancy term from the book. And this is simply the distance between what the user wanted to do and what actually happened when they performed an action. And like I said, this is one of the most frustrating things, so we need to avoid it whenever possible. So how do we prevent this miscommunication? How do we straighten out our wires, make sure everything is clear and obvious and no one ever gets confused? If you have a way to do this, write your paper, get $1 million, and please tell me how. Because there is no simple solution. But that doesn't mean there is no solution. We have some tools. The first is simply to use better names. I use the example of justify content and align items. Why on earth are they called that? Surely it should be something like align main axis and align cross axis. The second you've got a better label for it, it becomes way clearer what's going to happen if you change that axis. If anyone here is part of the CSS development team, I doubt. If any of you ever watch this talk, please fix this. It's my most hated thing. The next tool we can use to avoid these kinds of gap of evaluation issues, these kinds of miscommunication, is to simply be consistent. Earlier, I talked about signifiers learned over time. If everything connects together in the same way, everything's repeatable, it looks kind of the same, it's great. That doesn't mean that everything needs to be exactly the same. It just needs to work in similar ways. For example, if I've learned how to drink a bottle of water, it now works in a similar way to a can. Oh, cool. And Lego, such as what I've got on the screen, is a perfect example of this in the physical world. There are thousands of different pieces of Lego. And if my notes are to be believed here, there's about 87,000 at the moment. That's a lot of different parts to put together. And yet, children work with these things, and they can put it together. And the reason for this is that they have a common design system. Even though all the blocks look different, they were very clever. They were like, we're going to have these precisely sized pegs, and everything is going to connect in this way. And we can do something similar with our API designs. We can make it so that all of our different API calls and functions and objects and classes and everything fit together like puzzle pieces. For example, once I worked on a component where we had to specify the width and height of the image. They were called width and height. Perfect. Then someone made an animated version of this, and the width and height were called the W and H. Don't do that. Make it consistent. Make it all work the same. Because the second you have an incongruous, oh, that's a big word, incongruous. I like it. Second you have an incongruous puzzle piece, people get very, very frustrated and they make mistakes. You get that gap of evaluation. You get that confusion. So how do we avoid all of this? How do we put everything we've learned here together? I promised you a real world example, and I'm going to give you one. You'll note there's a little asterisk there. That's because I had to abstract away some of the details, smooth away the hard edges, make sure I'm not leaking client code because they will get angry with me. So let's jump into it. Suppose we have an online store, and we have a user that would like to buy one of our products. Our online store operates out of two warehouses, two locations. We'll call them Joburg and Cape Town. And a user in Joburg can buy products A, B, and C, and a user in Cape Town can buy B, C, and D, but notably not A. And similarly, someone in Joburg can't buy product D. So when we got this system and I had to build the front end for it, we got some APIs alongside it. One of them was we could get the currently logged in user. We'll get their name, we'll call him John, and he's in Cape Town today. We then have another API, get/products, that lets us know what products are available for purchase and gives us all the relevant information and whatnot. So far, so good. If we want to make an order, we make a post to products. In this case, if I want to buy product A, I'm going to make a post with a single item A in it. This is a little bit dodgy because if I post the /products, someone might expect that I'm adding a product, not making a purchase necessarily, but it's workable. What really killed me, though, is when we made this purchase, we get this error. Internal server error, product unavailable. And we looked at this and we were very confused because like proper developers, we didn't read the business rules, we didn't read all the docs, we just started coding. Does product unavailable mean that product A doesn't exist? Does it mean maybe it's out of stock? Or does it mean what it actually means in this case? If you're in Cape Town, you're not allowed to buy product A. Once we learned about this, we asked for an API to let us see whether we are able to buy a product beforehand, because we don't want to sell users on something that they won't be able to buy. And so the people who worked on this API gave us something interesting, something I'd never seen before, something that confuses and vexes me to this day. They gave us an options call. Who here has ever used an HTTP options call? Wow, more hands than I thought. I saw, I think, 2 people there. Uh, I actually have an image of all the devs I know who've used options before. Here they are. So how do we fix this? How do we turn this API from something that's confusing and so confusing that I got up here to give a talk to you guys today and turn it into something good? Here's the game plan. We are going to use everything we've learned so far. We are going to make the API more discoverable so that people know what they can do with this thing. We're going to do this by signifying to our users what actions are available, which is interesting to do with code. We're going to ensure that the results of our API are predictable. We don't want anyone to get an error and say, why did I get this error? We want them to know, oh, I did something wrong, or ideally, they should never make the error in the first place. We're going to give the user better feedback so that when they do run into these errors, they know exactly how to fix it. And finally, we're going to help the user build a good conceptual model over time so that as they use this API, they will never be confused again. And finally, because once again, I lost a line there, we're going to pat ourselves on the back for communicating well. Cool. Let's get around to fixing this. The get API product is good. But let's maybe replace that options call from earlier with another get request. We're going to make get/API/available product. And this signifies to users when they're looking at our Swagger or reading our documentation that not all products can be bought. This is how we signify with code. We just make it clear in our docs. Cool. Now that we know that some items can be bought and some can't, and we have a way of getting which items can be reliably bought, let's go on to fixing the rest of the stuff. Simply posting to /products is confusing. Like I said, that could mean I'm adding a new product to our inventory, not necessarily making a purchase. So let's replace /API/products with /API/orders. Now, if I post to orders, I know for a fact I'm making a new order. Our API is now more predictable than before. Finally, we're going to give better feedback. Instead of saying internal server error, product unavailable, we're going to split it into multiple ones. We're going to have one for product out of stock, product not available for purchase in Cape Town, and maybe product doesn't exist. I didn't put an image up for that one. And once we've made all of these changes, our users are going to be able to build a good conceptual model. They're going to understand how our API works, and no one is going to have to go Google if options is an actual API call that you can make, which I did. And with just a few simple changes, we've turned this mildly confusing API into a pretty well-made one, if I say so myself. Cue applause and fireworks. I did ask. Apparently, we're not allowed to have fireworks. It's a fire hazard or something lame like that. I would have bought them myself, but they said no. Cool. So let's take this and maybe distill this into our final big idea for the day. The final thing you can take away from this talk. But before that, we're going to replace our game plan because I lied to you guys. This wasn't just the game plan for this example. This is a general checklist for how you can build a good API and how you can build good interfaces in general. You want to make it discoverable. You do this by showing the users what they can do. You ensure that the results of your API are predictable. Wherever possible, make sure that your users will never be confused what's going to happen when they call an endpoint. We're going to give good feedback. Please no HTTP 200 failure. Never do that. And we're going to help our users build conceptual models, and we're going to be proud of ourselves for communicating well. And now, the final big idea. This entire talk distilled into a single line, to a single sentence, that if you remember this, you'll be able to build good things for the rest of your lives. And it's a really simple idea. Good communication is good design. Communication is at the heart of all design. We build our APIs for other people to use, not for programs. And people communicate with each other, and they do it well. If you don't communicate well, you will have a bad API. So please, remember this and take it forward with whatever you build. I think I'm a little bit ahead of time, but that's all for today. Thank you guys for coming to my talk. Cool, sweet. I wasn't planning to take questions, but if anybody does have any questions, let me know. You see, this utter silence is an absolute, I love it. It means I've communicated well. You guys understood everything I said, and I don't need to expound on that. Nice. Yeah, I don't see any questions, so I think we're done for now. Thanks, guys.